Okay, so this is the first lecture of this course, the introduction. Computer security problem. There are two major factors. The first, there are a lot of buggy software. So bugs in the software comes from the complexity. For example, Linux kernel has about 28 million lines of source code. Windows kernel is even much larger. So because of the complexity of modern computer software, there will be a lot of bugs in the software. Okay. Second, money can be made from funding and exploit vulnerabilities. So there is a marketplace for vulnerabilities. You can sell those vulnerabilities. Actually, there are some people who can make a decent living by funding and exploiting vulnerabilities. There is also marketplace for owned computers. So an owned computer, usually we call it a bot. So if you have a fleet of owned computers, you can build a botnet. With botnet, you can do a lot of malicious things, such as distributed denial of service attack. Okay, there are many methods to profit from owned client machines. So this is the current state of computer security. So because of this, right, there is a place to sell and buy vulnerabilities. So people can make money from those vulnerabilities. So if you know what's the most popular malware currently in the market, that would be ransomware. Ransomware. Okay, so this kind of malware, it will encrypt your files. Okay, then ask for a ransom. Only paying a ransom will get your file back. If you refuse to pay the ransom, so they're going to post your file on the internet. Okay, so here let's look at a quick example. Let's go to here. Okay, here you can find the information about this ransomware. Okay, normally you should not visit this website, right? So, but for the education purpose, let's take a look. If you look at this, National Wire Cable Corporation, so you can see there is a lot of files. In this case, it's mostly in some case of the image file. I have opened this, so it's actually a Christmas photo. Okay. Okay, so this is a ransomware, right? So they are going to encrypt your file. If you refuse to pay ransom, they're going to post your file on the internet. Okay, so this is the vulnerability disclosure tracked by MITRE. This is the organization to keep track of the vulnerabilities. So the data was from 1969 to 2010. So if you look at this, the number of vulnerabilities actually steadily increased. uh, okay, so this is actually affected by a number of things. Like first, we are paying more attention to security. Security becomes more important, right? Then we're actually getting better at finding vulnerabilities. Okay? So this is mostly supported by a tool called fuzzy testing. So we're going to talk about some topics in the fuzzy testing. So on the right side of this screen, you can see the web application vulnerabilities as compared to others. So the web application vulnerability is about half of the total number of vulnerabilities. Okay. So the most exploited vulnerable programs. So this data was from 2016, right? So this is important because one of the most vulnerable programs will soon disappear. So think about what are those possible vulnerabilities. Okay, so the largest one is actually Oracle Java. Right? So the Java is a managed language. So it means that for vulnerabilities like a buffer overflow, it shouldn't happen in this kind of software, right? So a buffer overflow will normally a buffer overflow happens when you try to write more data into a buffer than its capacity. So they are overflow the buffer. You are writing too much content into the buffer. But for managed language like Java, right? So the compiler will insert additional checks, security checks. Every time you try to write it into buffer, it's going to check whether it will overflow the buffer, whether it's within the range. Okay, so Java itself should be pretty secure, right? Because it has so many additional checks added by the compiler. But why it is one of the most vulnerable programs? Okay, so this is something called a Java virtual machine, right? If you think about this, when you write a Java program, you write it in the Java source code, then you're going to compile it. Normally it's called Java-C into a Java bytecode or bytecode code. So the Java bytecode will be run on the Java virtual machine. Okay, it's try to interpret the Java bytecode and execute it. So Java virtual machine supports a lot of fancy features. One of them will be just in-time compiling. In this case, it will monitor the execution of the Java program and say which part of the program will be executed most frequently. Then it's going to use just in-time compiling to turn this Java bytecode into a native binary. Okay, into the native binary. So also Java virtual machine needs to interact with the operating system, right? So for example, it supports networking. It supports access to the files. It supports media. So all those components are actually written in an unsafe language, the C and the C++. So even though the top layer of your Java program is more secure, but its foundation, the Java virtual machine, is written in a very vulnerable program. Okay, in addition, at this time in 2014, when you install Java from Oracle, or previously will be the Sun microsystem, right? So it was Sun was sold to Oracle, right? So when you install Oracle Java, it's going to install something called Java Web Start. So the Java Web Start is a piece of browser plugin. Okay, it's a browser plugin. So it means that GWS, it's a native binary. It's loaded by the by the browser. So if you go to a malicious website, so they can detect whether you have Java installed in your browser. And if they found that you have a vulnerable version of Java in your browser, they can exploit your Java virtual machine. So this is why Oracle Java, even though it's a managed language at the upper layer, it's still incredibly vulnerable. Right? The second most vulnerable software is the browsers. So some people call a browser a second operating system. So if you look at the functionality of browsers, it has a lot of functionality which appears in the operating system. For example, it has a graphic user interface. It has its own programming language called JavaScript or Web Assembly. Web Assembly, right? Then it can play media. It can access file. It can access a network with something like a WebSocket. Okay, so browser also has a lot of plugins or extensions. So the browser has a lot of functionality, right? So it also has a huge code base. So browser is the second most exploited programs. So if you think about this, browser is also ubiquitous. It means that it's installed everywhere, right? So this is why they targeted the browser. The third one will be Adobe Reader. This is a PDF reader, right? But for Adobe Reader, it actually has a lot of unexpected functionality. For example, it has JavaScript. So the JavaScript can be used in forms or PDF forms, right? You must have filled in some PDF forms before. Sometimes it can do a validation of your input. Right? This is actually done by the JavaScript. So it has a media library. Okay. It also has something like 3D models, a lot of extra functionality in the Adobe Reader. So there's another one is the Adobe Flash Player. Okay, Adobe Flash Player, thanks to Apple, so it will mostly disappear from the internet, which is definitely a very good thing, right? And also the Microsoft Office is also very vulnerable. Android operating system also has a lot of issues. Okay, vulnerability and exploits. What is vulnerability and what is exploits? So to define vulnerability, we need first to define a bug. So a software bug is a place where real execution behavior may deviate from the expected behavior. So this is a very broad definition. But a vulnerability is a vulnerability is a security sensitive bug, right? They can have a lot of different types of bugs, such as functional bug, right? So if the function of a program is different from that of the expected behavior, you have a functional bug. That's not a security sensitive bug. So a vulnerability is a security sensitive bug. So the exploit is an input that gives attacker an advantage. Usually, an exploiter targets a vulnerability. Okay, so because there are a lot of modern defenses, such as address space layout randomization. Okay, to take over a computer has become more and more challenging. Normally, you cannot use single exploit. You should use a chain of exploits if you need to take over a computer, right? So an exploiter can target many different things, like control flow hijacking. It targets the control flow. It gains the control of instruction pointer or EIP. So EIP or instruction pointer always points to the next instruction. Okay, so if you can change the instruction pointer, you can control the execution flow of the vulnerable program. So the control flow is basically the execution path of your program. There is also a data flow. Data flow is the flow of the data in your program. Right? So you often hear about it. You often heard about something called a data flow analysis. Okay, it analyzes the data flow. Then there is also denial of service attack. You can cause the program to crash or stop servicing clients. So if you can crash the kernel, you can cause a denial of service of all the programs running on the computer. So if you can crash the virtual machine monitor, you can crash all the guest operating systems, right? So this is a typical example of denial of service attack. There is also information disclosure to leak private information such as password. Sometimes it could be the private key of your server. So top targeted high-risk vulnerabilities. So there are a lot of bugs in the common program. For example, Ubuntu Linux has over 99,000 known bugs, right? So it could be security bug and also a lot of other bugs. So the old vulnerability even fixed means there is already a fix or a patch provided by the vendor, but it can still exist in the user systems. So here is an example, right? CVE 26, 2006, 3227 is a top thread after almost 10 years. Okay, so the CVE is a database to keep track of vulnerabilities. So every vulnerability tracked by CVE has a number. So the number contains three components. The first is CVE, second will be the year of the vulnerability. Then you have a number of this vulnerability in this year. Okay, so if you look at this case, it means that this will likely there will be more than 3,000 vulnerabilities before this vulnerability has been reported, right? Okay, so if you look at some product like Internet Explorer, so we have mentioned the browser is one of the most targeted program, right? So the Internet Explorer is a typical example of this. So the Internet Explorer was incredibly vulnerable. There are a lot of high-profile vulnerabilities related to Internet Explorer. A few days ago, Microsoft says we're going to kill the Internet Explorer. Instead, we're going to use something called Microsoft Edge Browser. So the Edge Browser actually has two versions. One version, the old one, is based on the Internet Explorer engine. Okay, so the new one is based on the Chrome engine. Okay, so if you look at this vulnerability is from 2006. So the data was from the 2015. So the second case will be 2009, 2010, 2012, 2013, and 2014. Okay, so in today's market, right? So if we look at the browser or browser engine, so we have a Chrome engine. Okay, this is a Chrome engine for the so browsers based on the Chrome engine will be like a Google Chrome, including the open source Chromium browser, right? So there is Opera, there is Microsoft Edge, there is Brave, there is many other browsers. Okay, so Apple has its own browser called Safari. So the Safari engine is actually a sibling of the Chrome engine. They both comes from the, I believe, the KDE engine. Okay, KHTML engine. So of course, Google put a lot of efforts to improve their engine, right? So now you have a single engine with a lot of different browsers. So the Chrome engine has the absolute leading market share. So because of this, the lack of diversity will also cause security problems. Okay, so usually you want to have more diversity than less diversity. So otherwise, if you have a single bug in the Chrome engine, it's going to affect all those different browsers. So the only engine which are not related to Chrome will be the Firefox. Firefox has its own engine. But a few days ago, they announced that they're going to have a layoff. Okay, so this really puts the Firefox into a danger. Okay, Microsoft Office. Okay, so let's also talk about something called a Chromebook. So the Chromebook is actually a computer. It's focused on running the Chrome browser. Right, so a Chromebook's main purpose is to run the Chrome browser. But of course, nowadays you can also run Linux apps and Android apps. So what makes Chromebook to stand out is something called a chain of trust. All the components on your Chromebook, from BIOS, the basic input-output system, or sometimes it's called a firmware, to the operating system. So the Chromebook are based on the Linux operating system. To the Chrome browser, all those binaries are certificated. Okay, so you cannot change any of those binaries. So Chromebook also has something called a Power Flash, or it's similar to a factory reset. So if you have any problem with the Chromebook, you can just do a Power Flash. It will reset the notebook to the factory status. Okay, so if your parents or family, they don't need all those different software, you can buy a Chromebook for them, right? So this will save a lot of the technical support headache. But of course, you can also run Linux apps and Android. It should be, it should cover most of the use cases. Okay, let's talk about the vulnerability life cycle, or how the vulnerability evolves, right? So here is an important concept. It's called a 0 day. Or 0 day. Okay, so the 0 day, or T0, is the day a vulnerability has been publicly disclosed. But before this, a vulnerability could have already been exploited. It's just people don't know this. Okay, the vendor doesn't know this. So at the date of the vulnerability disclosure, it becomes 0 day. It means that this is a new vulnerability or new exploits, right? So people just get to know this problem, but there is no patch exist or not. It existed. So then you have the patch. So the vendor will develop a patch. So after you release the patch, so the patch will be deployed. So the patch deployment is very important for the security of the whole ecosystem. So what makes Chrome browser stands out is that if they release a new version, so in a few days, almost all the Chrome browser will be updated to a newer version. If you think about the number of user of the Chrome browser. So this is actually another easy technical problem. Right? So it's just a lot of data needs to be sent out from the Google to the user. So what they do to solve this problem is using something called a binary patch. Okay, so or bindiff. So if you think about this, right? So if you have a Chrome 84 to Chrome 85, so most of the binary of these two versions will be very similar, right? Okay, so the binary diff actually say compare the binary of those two versions and create a patch file to be applied on Chrome 84, then you will get Chrome 85. Okay, so this will significantly reduce the data they need to transfer in order to update the browser. Okay, so because of this, so they can quickly deploy the Chrome browser. So without cost a lot of traffic, right? So an interesting thing after the deployment of the patch is that new exploit will appear. So this is because a patch contains the detail of the fixed vulnerabilities. So for example, if you have a missing check, right? So in the patch, you are going to have a condition added into the program. If you do the binary diff of unpatched binary with a patched binary, okay, so you have you can do a bin diff. You will know where the change is. Okay, then by studying the change, you can say, okay, how can I trigger this condition? Right? If you can reliably trigger this condition, then you have a new exploit. So as soon as a patch is released, new exploits will come out. So there have been some research to generate the patch exploit based on the patch. So this is the automated process, right? Okay. So if you look at this, the last stage is the complete of the patch deployment. So this is actually could take a very long time, or sometimes we call this long tail effect. So you're going to have a long tail of the user which will not deploy the patch, right? So if we go back to the previous slides, you can see even the vulnerability from 2006 is still being exploited after 10 years. Okay, so this is the first part of this video. Okay, let's stop here.